However, we have to consider another 4 units going the other way, and we end up at -4. So for anything dealing with absolute value, we have to consider 2 scenarios. Okay, we have to consider going to the +4 and to the -4. Now, personally, I like to think of these as location points. Okay. The location point 4 and the location point -4. Now, it could be 4 units if we shift this whole thing over, say 5 and -3. That would also be 4 units, or 3, 4 units, except that one would be our middle. So it all depends on when we work these problems, what we get. But the formal definition is, how many units am I from 0? All right. So let's, now I should point this out. But think about geometry. Remember doing the distance formula and even taking square roots. You never really worried about this negative number because distance was always a positive number. That's why we always use absolute value symbols, because whatever comes out of there is positive. So with an equation, you have to consider this scenario or this scenario, I should say, or. That's why whenever you have an absolute value problem, you're going to have 2 equations or inequalities to solve. Okay, so let's take a look at, I believe I did problem number 4 in your practice packet. Okay, so problem number 4 in the practice packet. Let's take a look at that. And this is 1.6 part 1 and number 4. Okay, the problem is I have the absolute value of 3a plus 10 minus 4 equals 1. All right, so with any mathematical problem or equation or inequality, you're gonna want to get, whether it's in parentheses or anything that's maybe a radical or something, you're always gonna want to get it by itself, that term by itself. So right now I'm subtracting 4 from this term on the same side of the equal sign. So I want to get rid of that 4 or undo it. So I'm going to undo -4. So I'm going to add 4 to both sides. And that gives me my absolute value of 3a plus 10 equals 1 plus 4 is 5. Once I have it isolated, the term, then I go ahead and start solving for a in this particular instance. So I got to consider both scenarios. Now I'm going to take what's inside my 3a plus 10, and I have to consider, I always put my negatives first. You don't have to, you can put +5 there, -5 here, but I always like put my negatives on the left-hand side. -5, or I have to consider the second scenario. Take what's inside and take what's there, +5. Now I've got 2 equations to solve. And if you want, put your dotted lines. Okay, I'm going to solve this equation. -10, -10, I get 3a equals -5 minus 10 is -15. Divide by 3. And a is going to equal -5. Or now I got to solve the other equation. -10 minus 10. I get my 3a. 5 minus 10 is -5. Divide by 3. And a equals -5/3. So this is my answer. Now, if you only put one of these down, well, you kind of miss the whole concept of solving an absolute value. So really, your grade on like on a quiz or something would go down pretty dramatic if we did things in real, not COVID. So be careful with that. On the SAT, they'll take off full. You won't get any credit. All right, so that's a example of an absolute value equation. Well, we're going to do the same thing with inequalities in part 2, except it's a little more involved, especially when we break it up and putting that and or statement in there. It gets way more complicated. There's one more thing I wanted to show you, okay? On problem number 6 in your practice packet, remember I told you guys you have to get that absolute value term by itself first. This time it's in a fraction, right? Everybody remembers how to get rid of the fraction before you separate it. So you end up multiplying both sides by the denominator 3, then split it up. Then split it up. Just to give you a little hint. That's just an example. One more example other than the video for 1.6 part 1. Anybody have any questions on this?